Hello guys, welcome to the stream. I hope everyone can hear me. So we ran into some technical difficulties, which is why the stream started a bit late, but we'll be starting right now. So, can you guys hear me first of all? Okay, I'm assuming you guys can hear me. So first of all, uh, we're gonna get started with the basic mechanics of Fruit Ninja. So this right here is a Melanode page. So Millenor is a really useful software for planning out game design. Like, if you'd like, you could make an account. So this is called a Millenor board. So right here, I've explained the basic concepts of Fruit Ninja. So first of all, I'll be starting with classic mode, which is the primary mode in Fruit Ninja. So I'm assuming most of you have played Fruit Ninja. Otherwise, you can download it from the App Store or the Play Store. So in classic mode, these are the rules. So first of all, fruits keep appearing and you have to slice them. If any fruit falls to the ground, you okay, as I was saying, each fruit has a different velocity and they move in different directions and different ways. So about the types of fruits themselves, there are multiple types of fruits, but the main difference is just the hitbox. So like the pineapple is bigger, the strawberry is smaller, but there are also special fruits. In arcade mode, there's different types of bananas, but in classic mode, the only special ones are the strawberry and the pomegranate. So the strawberry explodes and the pomegranate lets you hit it multiple times. And the other big game mechanic is the combos. So if you slice multiple fruits at a time, you get extra points. So if you're actually going to implement this, then what makes it one swipe would be the time period taken to complete the swipe. So we could have it like 0.5 seconds. And there are also some fruits which just give you random criticals, which would just give you 10 points. And every time you score 100 points, you gain a life. So those are the basic game mechanics of Fruit Ninja, and now we'll be trying to implement those in Unity. So now, what we're going to start with is Unity's input system, specifically the new input system. So Unity has like traditional system which had like get axis, get axis raw, get button, etc. But the new input system is a lot more handy and a lot more intuitive, but it's also a little bit harder to understand. So first of all, I'll explain how to install it, and then I'll explain the types of inputs. So now let me go to the full screen. Okay, so now this is Unity Hub. So just a second. Okay, so for this, the type of game we're going for would be 3D mobile because all the assets are in 3D. So if you don't have the module downloaded yet, like there should be like some download button, I guess. But if you're worried that it'll take too long, then Even just going for regular 3D is fine, but I'm just gonna go for 3D mobile. Like regular 3D shouldn't make too much of a difference. This should just be a bit more. It'll have some of the packages pre-installed. So now we press create project. So now this project is getting created. So another thing that I'd like you to keep in mind is you need to have the Android or iOS module installed. So this is the version of Unity I'm using. If you want to add modules, you press add modules, and then you can add iOS build support and Android build support. So we won't be using this today, so if you haven't installed it yet, you can install it by the next session. But just keep that in mind. Like we'll need this to ship to your phones. Or if you just like to ship it to your Windows or Mac, then you wouldn't even need that. But I recommend downloading these. So I guess the project is created now, so I'm gonna open it. Okay, it's already open. It's already opening. So this will take a while. So we'll just wait a minute or two for this to create. Okay, so first of all, we're going to set up the input manager. So if it's already installed, then you can go to create, scroll down here, like press this arrow, and you would have the new input manager here. But we didn't set it up yet, so what you have to do is you go to window, you go to package manager, you press this, and you go to Unity registry. And here, uh, this might be under 3D. uh, no, mobile. Okay, in that case we scroll down here, uh, we go to input system. So this right here is Unity's new input system. So it's currently at version 1.5.1, which was released on March 24. So it's the latest version. So now what you do is you press install. So since this is in Unity's registry, like I believe like there is no download, so I think it's just an install, so it should be done pretty quickly. Let's see. So it'll ask you to restart your editor, and uh, you should click yes. Okay, so now it's gonna restart, so we'll have to wait a little while again. Okay, so the project has opened for me again. um, let's see if it's been installed. Okay, so now if we scroll down, we go to the input system. So this right here, it says Okay, the tick mark indicates it's installed, and install has been replaced with remove. Hmm, I guess these are some custom sort of samples for the actually, let's see, the input asset. I, so first of all, what we need to do is we need to go to project settings, and right here in the input manager, no, the input system package. So the input manager is for the old input system. Input system package is for the new one. So create settings asset. So this creates this asset here, which is um, basically it stores all the settings. So this is like the dead zones if you're using a controller. So like the dead zone is like the zone where you won't detect any input. These are like the button release thresholds, the tap time, like uh, how much time delay there should be to register a tap, all of that. So we won't be needing to deal with this much today, but if if you need to adjust any of the settings for the input system, this is where you go. So we'll be creating our asset in the scripts folder because it is a script. So we create a scripts folder, we open it. So now we create a C# script. So, or actually no, not yet. Okay, let me just delete that. Okay, so what we need to create is input actions. So by default it's called new controls. Let's call it touch controls. And now you can double click it and you can open it. So this is where you store all your inputs. So these are your action maps, and an action map is a group of actions, and an action is pretty much an input. So let's call this um, touch map, and here we can set our actions. So the first action is going to be called primary contact. So basically this is sort of a boolean, you could say, that tells you if you've pressed something. So uh, we set the action type to pass through. So basically the action types work like this. So value is what you use for something whose value changes continuously. So if it's the, let's say, the position of the analog stick, we would put that in value. And button is for like buttons, like something you trigger once and you're waiting for that input, so it's not continuous. And pass through is almost the same as value. So in value, if you have multiple inputs, it chooses the, I guess you could say, the best input. So it has a disambiguation process. Meanwhile, in pass through, it you can access all the inputs and you can deal with each of the inputs separately. So we're going to go for pass through for this one. And control type is going to be button because um, primary contact is when you press the screen, it needs to trigger an event. So it practically acts as a button. So we go to binding, we go to path, and we select touchscreen. So binding is basically like what the action is bound to. So like if it was keyboard, then you could assign it to, you could bind it to something like spacebar or backspace, and you could press this and you could make it listen to it. Okay, I don't think that was how that worked. Oh yeah, you need, if you press listen and let's say shift K, then it would bind it to K. But for touchscreen, we can't really listen because, um, my laptop doesn't have a touchscreen. So we go to touchscreen, then we go to primary touch. So basically, you can have up to 10 touches, okay? And because it's pass through, we can, individually choose. But I believe primary touch is the first touch. So here we go to touch contact. So that lets you know when you've pressed something. And in interactions, we add press because we are pressing something. So that's primary contact and that's primary touch. So we need one more, which is for the position. So uh, first of all, uh, click save asset. So that's how you save the asset itself. You can also set it to auto save, but that's your choice. So the next thing you do is you add primary position. So we will make this um, a value, or actually we can make it a pass through. And but instead of button, we're going for vector 2. So basically, since it's the touch screen, yeah. So the touch screen is a 2D coordinate system. It gives you the point in screen space, as in like what part of the actual screen are you touching. So it'll return a vector 2. So in binding, we go to touch screen and we select primary touch position, and then we hit save asset. So now um, we've saved the asset, and now if you want to access this through a C sharp class, all you got to do is click this generate C sharp class. These are the default settings. So this is going to be the name of the file generator, the name of the class, and the namespace, which is default global. Then we hit apply. So as you can see, we got a new touch control C sharp script. So we won't be dealing with this directly, like there's a lot going on here, but we'll be accessing this through another script. So now what we do is we go to window, um, let's see, analysis, and there was an input debugger. Yeah. So basically, since we're using since we're using PC, you can't, we don't have a touch screen. So instead, we're gonna simulate the touch screen. So it's in, yes, you go to options, simulate touch input from mouse or pen. So now we have simulated touchscreen as one of the inputs. So now we can go ahead and close this, and we will be creating an input manager. Okay, so first of all, before we go into the input manager, um, we need to get used to the idea of delegates and events. So in the input assets, so every time there's a touch, it triggers something called an event in Unity. And same thing with the primary position. Every time the position changes, or actually every frame, it it triggers an event, and you access the data through that event. So first of all, to find out what an event actually is, like I'll be creating another scene, so you can follow through with this. Like it's not gonna affect the final game, but it's nice to test around. So let's just call it event, no, delegates and event testing. So yeah, it's this slide. So um, we are okay. Just open that scene. So first of all, we'll just create, let's say a cube, 3D object here. So okay, it's not in the game view, so we just go here, reset the transform. It should be right here. Okay, so let's create a new script. Let's just call it delegate testing. Okay, so let's open this up. Okay, so the first ever thing we're gonna do. So let's just clear this up and let's create a public delegate function. So first of all, what a delegate function is, it's like a container or variable for another function. So basically it holds a function and you can change it at runtime and call it. So I'll just demonstrate that here. Let's call it public delegate void uh, dtest, and let's say we have an int num. So this is the syntax for it. So what this is saying is we are expecting a function which is of type void and takes an integer as an input. So basically how you initialize this is you kind of create it like a variable. So we just go with dtest um, test, and now let's just create a start method, and here let's create two functions. So first one I'm gonna call void um, print 5, and let's say we have int and let's call it 5, and here we can just go with debug.log um, 5, or actually let's not call it 5, let's just call it print 0 and print 1. Int num 0, let's call it num 0, and another similar function, let's call it print 1, int num1, and a debug.log num1. Or actually, let's go with a num1 plus 5, just to make it a bit more interesting. So now what we can do here is we can go like test equals print 0. There's no argument given that corresponds to okay. So here we don't use the parentheses, because if you use the parentheses it means you're calling the function, but if you don't use the parentheses you're assigning just the function itself. So this is like a reference to this function. Like think of this as a container or a variable that holds this. So let's go with test of 5. And let's go back into the editor. We just add this to the cube, delegate testing. So now hit play. This should work. So as you can see, it prints 5. And now we can just go back to this mode. Um, let's say we assign test equals print print 1 and then test of 5 again. Just save. So now we can come back here and hit play. So we can see that it logs 5 first and then 10. As you can see here, the delegate function test was storing print 0 and then it stored print 1. So now let's see. Yeah. So let's create another delegate testing function, or actually just edit this. So what you can do is you can multicast functions. So you can assign more than one function to the delegate. So for that, let's just create a transform move function. Let's just create start. Just remove this. Let's see, void move up, and let's go with transform dot position dot y plus equals 2. Cannot modify. Oh. Let's see, is there a transform dot move? No, there is not. Okay, in that case, transform dot position plus equal new vector 3 0 2 0. And similarly, let's create a move right. Hit Control D to just duplicate that. So move right. So here, instead of 2 on the y-axis, we're gonna have a 2 on the x-axis. Now let's just test out one of the delegates. So test equals move up, and then we call test. Okay, so on void start, this should trigger. So as you can see, this moved up by 2, like it was originally at the bottom here. Let's try this again. See, it moved. So now what we can do is we can assign both of these to the same function. So you can have a test plus equals move up. So basically, instead of the assignment operator equals, we're using plus equals. So it's basically test equals test plus move up. So this is the syntax for multicasting. So now we can also have a test plus equal move right, and we can call test. So as you can see, it moved both up and right. So that's what multicasting does. And as general practice, before you call any delegate function, you need to check if it's not null. So you need to check if test not equal null, then call test. Because if you don't do this, and let's say your delegate function is empty, it's going to cause an error. So yeah, this moved up. So now we're going to look at events, and events and delegates are all almost the same. The only difference is events cannot be triggered outside the class that they're defined in. So if I take this delegate test, and let's say if I made it public, I would have been able to access it in some other script, and I would be able to call this. But an event is something that can only be called um, like that can only be triggered within the class itself. So let's just try that. So so the syntax for making an event is pretty much the same. You just add event here. So it would become public event test. Naming rule violation. Okay, let's fix that then. Call that test. Or not. Let's just keep it that way. So now let's go to another function, like um, let's call this event testing. Event testing.cs. Okay, so here let me just double click that. Yeah, so here the type of the event is just a void with no arguments. So let's create a start function and a void, let's say uh, let's call it message. So we'll just um, do a debug.log message here. So debug.log event triggered, and here, so what we can do is we can make this event public static. So the static keyword means that it becomes a member of the class itself, and you don't need to create an object to access it. And the value of this will be the same across all instances of the object of the class. So what this means is we can just go uh, delegate testing dot test plus equals message. So uh, the advantage of this is we don't need a reference to this particular um, delegate testing script. So like if you didn't use a public static event, what you would have to do is, you would have to make a public delegate testing, like drag it in from the Unity editor and just keep adding all those references, which would be really really messy in the end. But here you just need the class name, just use dot and access that event, and wherever the delegate testing script is, it'll trigger that event and it'll call this. So let's test this out. Yeah, we are calling this here. So now, did it debug log? It seems like it did not. Okay, that might be because this was added later. Let's see. Move right. Okay, what if I put this in awake? This might help. Nope, that did not work. Just give me a second. I would need to add this to something else, I guess. Void on enable. Oh, okay, I got the problem. It's because I didn't assign an instance of this class. Okay, so just need to add that script to my cube. So event testing. Okay, this should work now, hopefully. Okay, so event triggered. So now the one difference between events and delegates. So let's go to let's create a start function and let's try to call delegate testing dot test. So now it shows an error because it's an event and it cannot be triggered outside the class that it's from. But if we remove the event, then this error goes away. So let's just try that. So this should be called twice now. Yeah, so the event was triggered twice, and yeah, I expected this to go up twice again, but oh well. So yeah, the primary difference between an event and a delegate function is that an event is more protected. So you'd use an event if you do not want any other function to call that. So this is just one of those things that you do, like let's say you're creating an API or something, and uh, you just don't want other developers to get confused on what to use and what not to use. So you'd make an event for something that's, you know, an event that's triggered within a script itself, and you don't want anyone else to trigger it with another script. So that's it for delegates. Now, like, we won't need these functions. Like, let me just delete the scene. So delegates and event testing. Delete uh, scripts. Delete delegate testing. And delete event texting. Okay, so those are gone now. So now what we're going to be doing is we'll be creating a swiping system using the new input system. So like just give me a second, I'll be right back. Alright guys, I'm back. So now we'll be getting started with the swipe system. So let's see, I think this should be my entire screen. Okay, so um, just to recap what we did with the input system, um, we went to create, we created an input actions, which is this. We added a touch map, then we added these two actions, a primary contact, which is pass through button, and its primary touch and touch contact. This is similar but with control type vector 2, and primary touch position. We saved the asset, and then we created a C# class and hit apply, and now we have the touch control script, and we have the input manager that we just created. So let's open the input manager, and let us clear this junk. So now the input manager is going to handle all the inputs in the scene, and we are going to only have one input manager in any given scene. So what you gotta do is um, basically we create something called a singleton class. So a singleton class is a class with one and only one object. So if you create more than one object, then it destroys the new object that you created. And the primary advantage of this is you can access that one instance from anywhere, like without reference to that instance directly. So creating a singleton is pretty easy. So first what you do is you create a public static input manager and you call it instance. So this is literally an object of the class, and it is static, so it's just common across all the instances. And it also means that if you want to access this, um, let's say in another script, um, okay, I deleted the other scripts now. Okay, let's just create a test script. So should open. Okay, so this is test. So what you can literally do is you can go with input manager dot inst. It's not allowing me. Let's see. I'll put it in start then. Input manager dot instance. Yeah. So basically, that one instance can be accessed within any other script directly by just going with class name dot instance. Like otherwise, what you would have to do is like you would create something like a public input manager, and then like um, let me just delete this. Yeah. So okay, isn't this the scene that I just deleted? Okay, let's go to classic. Don't save. Yeah. So let's create another cube here. Attach the test to it. Yeah. So what you would do traditionally would you would create a game input manager empty object, then you have to drag this into the manager here and then access everything from that, which is a huge hassle. So instead what we do is we just um, clear this out and just create a private input manager, and then you can just go with manager equals input manager dot instance, like that's it. So let's just clear that code for now. Okay, so now what we do is we go to the awake function. So first, what we are going to do is if instance is null, we make this instance the instance, otherwise we destroy it. So we go with if instance equals null, meaning there is no instance, then instance equals this, and else we can just destroy this. So I'll show you what this means. Um, so let's say we let's say I create an empty and I call it managers. So like we'll be storing all the managers in this object, like including input manager and the game manager. So let's take the input manager, put it here, and just hit play. Hopefully no errors. Yeah. So basically what this script means is if instance equals null, instance equals this. So this script is attached to this input manager. So um, what do you call it? So the instance will be set to an instance of this. So let's create another empty, call it game object, and there should be input manager. Like as you can see, the moment you try to add it, it just destroys itself. And let's say I remove this. Okay, we hit play. Yeah, we add an input manager, it's fine. We try to add another one, it's not fine. We try to add an input manager here, no, it just destroys itself. So that is basically what we're doing. So let's just add an input manager here. So another thing we're going to do is we're going to change the default execution order. So basically this is the way you do it. Like you open the square brackets, you go to default execution order, and you set that to -1. -1 just means it'll be before everything else. So that's a simple reason we're doing this. So we want the instance to be instantiated as soon as possible before all the other scripts start to access it. So like if I would make an awake function and I had to access, input manager dot instance. So if this did not execute first, then Unity would be like, hey, you're trying to access something that doesn't exist. So we changed the default execution order. Alright, so that's the basics of what a singleton is. Now we'll be getting to the actual player input. So let's just go up here. Let's create a private. What was the name of our? Yeah, touch controls. Touch controls. Let's call it inputs. Okay, it's pretty easy. And let's see, I could put that in start, I suppose. So what we're going to do is we're going to create an instance of that touch controls. So inputs equal to new touch controls, and now we need some functions to enable it. So we create the on enable function. So basically this is called when you like enable and disable any script. No, I mean it's called when you enable it, and the other one is on disable, which is always called when you disable a script. So let's see, touch no, inputs dot, I think, enable, yes, and on disable we go with inputs dot disable. Okay, so now um, yeah, in void start we add this. So inputs dot prime wait oh yeah, inputs dot touch map dot primary contact. So it's like this: name inputs, then the name of the action map and the name of the action, and then dot uh, we'll create something for the started function. So basically, this started is an event, just like we discussed earlier. So, like if you see the lightning symbol in Visual Studio, that means it's an event. So we are going to add a function to that. So um, we add it like this: ctx, which means context, and this is basically a lambda function. So let's call it start touch primary ctx. So let's just create a function for that. We'll call it, yeah, start touch primary, and input, wait, oh yeah, we need to import a C sharp library. So here it's using a unity engine dot input system. So now we create that function that we just wrote there: start touch primary input action dot callback context. Yeah, make it a void. Okay, so basically, first of all, I need to explain what a lambda function is. So basically, what a lambda function is, it's like a shortcut to create a function on the spot. So we could go, I think, void test equals uh, no, does that work? Okay, I do not think that's a syntax for like assigning one. But basically, you go with like huh, okay, I'll explain the syntax of the lambda function later, but basically it's just a shortcut to create a function. So this event, primary contact dot started, it returns a context. So it's of the type input action dot callback context, and that goes as input into the start touch primary. So basically, just use this syntax every time you're creating a function to add to the event. Similarly, we need something for when it is what do you call it? When you lift the finger off your screen, that would be input, no, inputs dot touch map dot primary contact dot uh, is there a finished? I think there's only a cancelled. Yeah, cancelled plus equals ctx and touch primary, and again void and touch primary input action dot callback context, context. So basically what's gonna happen is when there's a primary touch, it's gonna call this, and when the touch is over, it's gonna call this. So let's just test that out. Debug.log touch started and debug.log touch ended. This should work, hopefully. So we have the input manager, not pause. Where is this? Input manager on enable. Wait a second. Where did I set the inputs? Inputs equal to new touch controls. Okay, in that case, I need to put that in awake. Okay, so as you can see, when I click it, it says touch started. When I leave it, it says touch ended. So we're on the right track. So now what we're going to do is we're going to outsource this as events. So uh, we're going to create two delegate functions. So public delegate void, what do you call it? We call this start touch primary. Okay, we'll just call this start touch, and we're gonna pass in I guess just one argument, a vector2 position, and we are creating an event for this. So public event, let's call it on touch started. Oh yeah, I need to add the type as start touch. And another delegate function for ending the touch. So public delegate void end touch vector2 position. Yeah. Position. Okay. So now again a public event end, no, on touch ended. Oh, public event end touch, yeah. So now we will be calling the event here. Let's just replace this and this. So if, what's that called, on touch started not equal null, then we're gonna send, we're gonna call this, and for the vector2 position, what we're gonna pass in is let's see, inputs dot touch map dot primary position dot read value vector2. So this is the syntax to read value from it. Not valid, huh? Inputs dot primary position dot read value. Oh, okay, yeah. So the thing is, this value here is going to be returned in screen space, so it's not going to be world space, which is what we actually need. So Instead of like going with this, um, okay, so first of all we're going to create a utils class. So we're going to create that just for utilities. So for just like utility script, so we call it utils. We're going to create something that what do you call it, yeah, converts from screen space to world space. So let's just create a private camera. So that's going to be the main camera, and here we're going to set um, yeah, main camera equals camera dot main. So it just directly gets the main camera. So that's the test. I need the utils. Okay. So there is camera dot screen. Just a second. Let me look this up. Okay, so we are going to return a vector 3. So public static vector 3. Let's call it screen space to world. No, just screen to world. And we're going to take a camera as input. Camera, camera, and vector 3 position. Yeah, need to. And now we're going to return camera. No, actually, first position dot z equals camera dot near clip plane. So the near clip plane is like the nearest point where something from the camera is rendered. Um, like we could set it to that. Like if you wanna have like some other custom behavior, like you could change this value to be something else. But we'll see what that means in a second. And yeah, and now let's see, return cam camera dot screen. It's not screen to viewpoint. Okay, I believe it's screen to world point. Just a second. Yeah, so screen to world point position. Okay, so we'll go back to our input manager, this public static. Let's create a function that just returns the primary position. So void primary position. No, not void, vector 3. So return utils dot screen to world, and then main camera. Then now we read that value, so inputs dot touch map dot primary position dot read value, and we read a vector 2. So this should auto convert it to a vector 3, and here we just get that primary position. Okay, and we do the same thing for n-touch primary, which would be on touch ended. Okay, so that is our events done. Now we need to create a swipe detection script. So that's gonna detect the swipes. So you go to C# script, you make one called swipe detection. Just let's put it in our managers as well. Enable it. So you won't need the update. We might need the start. Okay, so we create. Just a second. Yeah, private input manager. Let's call it manager. And in start we have, let's do that, manager equals input manager dot instance. Since it's a singleton, we can just do that directly. So now the first thing we're gonna do is create a swipe started and a swipe ended function. So void swipe started, make one of those. So for swipe started, we could leave that empty for now. Void swipe ended, leave that empty, and create an on enable and an on disable. I guess I'll put this in a week, because otherwise we need this to be called before on enable is called. So on enable we can just go with manager dot on touch started plus equals swipe started. No, it. So what did the start touch take? A vector 2, right? To start position. Okay. And duplicate that. On touch ended, we replace that with swipe ended. Yeah, need to put a vector 2 position there as well. Okay, so now on enable we're going to add these events, and on disable we're gonna remove those events. Let's see, did I put the not null in this? Yeah. Okay, so now what we're gonna do is we are going to create a trail. So basically we want like the cursor to like view what we are swiping. So for that we'll create an empty object, call it trail, and then we add a trail to it, a trail renderer. So these are a few of the settings. I guess I could enable this and show you if the trail's visible here. Yeah. So basically what a trail does is like um, it's a trail. So as you move it, it's gonna like just go out like that. The time 5 is a bit too much. We could set it to 1. Even 1 is too much. 0.5. So basically we are going to assign the trail to where our cursor is. So we exit play mode, um, set this to 0.5, um, and let's create a material for it because that purple thing is kinda hideous. So we go to material, let's call it trail mat or trail material, create a materials folder. Okay, go to materials, then we go to unlit, color, let's make it red, then go to the trail, put the color there. No, we put in materials. Yeah, put the material there. Now we test out this thing. So that's a lot better, but we need to make this less wide. So here set this to 0.5. So now its length is constant, but um, we need to make it non-constant, so we just add another point by double clicking. So now the tail of it is going to be, a bit smaller. Let's raise it a bit. That's a bit better. We can increase the corner vertices, and that would make it a bit smoother. If you increase this, then it becomes rounder. So let's just exit play mode and make those into 2 and 3. Add this somewhere along here. So now this trail should look good. I think it's good enough. You can just edit it later. Okay, so now coming to the trail renderer. So we are going to create a coroutine to render the trail. So first of all, let's create a public a trail renderer. Or let's just create a public trail. Now in this trail, let's go to on swipe started. We're going to enable the trail, and um, in swipe ended, we're going to disable it. Trail dot set active false, and we're going to create a coroutine. So enumerator, let's call it update trail position. So this is a coroutine, which is something that kind of runs parallelly to the other functions once you start it. So you use this for like time-based stuff. So now you create a while loop, and we can just give a while true here, and now we can go with trail dot position transform dot position equals manager dot primary Did I make that public? Okay, let me make this public vector 3 primary position. So now I should be able to access this, and I can give a yield return null, which basically means that it's gonna execute every frame. So if you wanna make it execute like every 5 seconds, you'll return wait for, let's looking for wait for seconds. Yeah, you wait for seconds 5. So that would make it wait 5 seconds before each loop. But we're just gonna yield return null, which means it'll just execute every frame. So now in swipe started, we're going to start coroutine, update trail position, and here we can stop coroutine, update trail position. Let's see. Now this should hopefully work. Where's our trail? Managers, trail. Let's test this out. So as you can see, the trail is kind of in the wrong position, and that is because we didn't set the camera's clipping planes properly. So if you just go to window, general, no, panels, layouts, 2 by 3. Yeah, so as you can see, like everything is just right in front of the camera because the clipping plane is like 0.5 or something. So now what we do is we go to main camera. As you can see, the Z is set to -10. So you see this whole thing. So this square is um, the far clipping plane, the big one you can see here, and the small one near the camera, if you zoom in a lot, is the near clipping plane. So we're just gonna make the near clipping plane like way over there, because it's gonna be a 2D 3D game, as in 2.5D, so we don't need this whole part. So since this is 10, we can set the near to around 9.5. Yes. And let's save the scene, hit play. Okay, so this should be a lot more accurate now. So that's how you get the trail renderer to work on the swipe. Just a second. Okay, so now we've created the trail and we're getting the position of it at every second. So now what we're going to do is we're going to make the swipe actually delete these objects. Okay, so for that to start, um, let's see, let me delete this cube and create a few spheres. So 3D sphere, and let's just call it a sphere fruit, because we'll be replacing this with fruits later. We reset this, uh, just create a bunch of these. So now what we're gonna do is we're going to do a sphere cast. So these have colliders, and the sphere cast is basically a ray cast, but over a wider area. So it's gonna cast a sphere. So if you don't know what a ray cast is, it casts a ray, and if it hits a collider, it returns what object it hit. So sphere cast is just an extension of that. So what we're gonna do is, first of all, we're gonna just use debug to draw a line. So um, let's let's create two private vector 2's. I mean vector 3's, or actually maybe one. Let's call it prev frame pause. So it's like the previous frame position in the previous frame versus the position in the current frame. And we can also create a minimum of this. So let's create a private serialized field. So a serialized private serialized field means you can edit it in the editor, but you can't access it through other scripts. So it's partially protected. So we can call this minimum swipe distance equals 1f, or let's set it to 0.5f. Yeah, private float. Now what we're gonna do in swipe started is we're going to first set that position. Just a second. Yeah, prev frame pause equals primary manager dot primary position. Okay, so just a second, I'll be right back. Alright, so now coming back here, um, we need to have another event which triggers every time there's a change in the swipe. So basically, for that we go back to our assets. You go to scripts, you go to touch controls, and you add another action. We call it primary delta. So this is going to trigger every time the swipe position changes, which is when we're going to check if the swipe has been detected. Okay, so the type is going to be value or pass through. We make it vector 2. The binding is going to be touchscreen primary touch delta. So we save the asset. Now it's going to regenerate that script. So now we create a public event delta. Okay, so for each raycast hit, we're going to set the transform of the hit object to false. So, um, okay, yeah, so the direction should still be out. No, it does not.